First of all, a very good noon, Sanmitra.
Hmm.
So,
Good news, sir.
how are you? Had breakfast?
Yeah, yeah, I've had my breakfast.
Great, great. So, what do you feel? How was your exam?
Uh, it was okay. I mean, not too bad, but I could have, I think, done better.
Okay, okay. So, can we have a small introduction of yourself?
Yes, yes. I am Sanmitra Das. I'm from West Bengal, and I have completed my graduation from Ramakrishna Mission Residential College, Narendrapur. The six SEM's results are out, but I have not got the hard copy yet.
Okay. So, have you given JAM?
Yeah, yeah.
So, what was your result?
Uh, I have secured All India Rank 3 with a score of 59.33.
Very good. That's remarkable. So, you have completed, like, you're completing your statistics, right, honors?
Yes, yes, yes. Statistic honors.
So, like, what are your favorite topics over there? What do you like?
Uh, it's a little tough to select favorite topics, but I prefer inference. I think inferential statistics.
Okay. What about mathematics?
No, I mean, okay. I think some topics in mathematics. Uh, Linear algebra is okay. I'm a little weak in real analysis, so I won't say that.
Okay, great. So, tell me, suppose you mentioned that you like inference. So maybe a very simple question.
Yes.
Uh, you have your data, right? X1 or
Okay.
X2.
Hmm.
And this will follow some distribution, some F
Okay.
theta, maybe. And I am saying a univariate parameter right now. So what do you feel like? How will you estimate theta in the first instance? I'm not asking about any rigid questions. I'm just asking the basic intuition of inference.
Okay. So if I have a set of data, then I try to form a function with those datas, and uh, with the help of that function, I will try to estimate the data and estimate the parameter. Sorry.
Okay, so what type of estimate can you give from the function?
Uh, I think what type of, I mean, I think point estimate, if the function gives a single real value,
Okay.
or
Is there any other type of
yeah,
estimate?
if I can, I mean, I can define two or more functions and have intervals to give an interval estimate. I think.
Okay, well said. So coming back to point estimate, so like the
Okay.
function that you have mentioned,
Hmm.
what is that? Will
Uh,
that, like, should it have any properties?
okay, so the function, I will call that a statistic if it's free from the parameters and just a function of mm the data. I think.
It will eventually be a function of data only because you
Uh,
have only
yes,
data,
yes.
right?
Uh,
Yes, yes.
and
So
I mean the distribution should be independent of parameter. I know. I think the function should be independent of the parameter which
okay,
I am
let
trying to
me
estimate.
reframe the question like this.
Okay.
So suppose you have a statistic or estimator Tx. Okay.
Okay.
So will, like, any form or any functional form of statistic is enough to estimate theta, or does this Tx should have some properties, some relevant properties such that I can actually hit that theta?
Oh, okay. So uh, there are some desirable properties like unbiasedness or having minimum MSE.
Okay.
I mean, I want to get as close to theta as possible with my estimates in terms of probability.
Okay. So any other characteristics apart from unbiasedness and minimum MC?
Uh, I think, I mean, the probability of, probability of mod t minus theta less than epsilon should go to. I mean, this should have a high probability. I think this can be a desirable property.
Okay, fine. So can you define unbiasedness?
Define. Okay, so the expectation of the statistic t under parameter theta should be the parametric function I'm trying to estimate.
Okay. And
Hi, Sanmitra, can you please write those things? It will be
Okay.
better for us.
Okay. I mean, this should be the definition of unbiasedness. I think if T is an unbiased
Is
estimator
it
of
so?
G.
so
Sorry,
this g theta, like what is this?
a function
I
of the
mean, is
parameter.
this correct, Sanmitra? Is this
Okay.
correct, his definition?
Uh,
Is this complete?
Uh, okay. So I can add this.
and what is omega?
No, it has meaning. It has a meaning. You shouldn't add, you are not saying that. You shouldn't say that. For all theta
Oh,
belongs to that script theta, it has a
huh.
meaning, deep meaning. You have to
Okay.
understand this.
Okay. Okay.
So we have to agree for all theta. It shouldn't like that some of the theta you are agreeing with the g theta and rest of that you are hitting somewhere else. That is not should be the
Okay.
unbiased
Okay.
characteristic.
Mm,
Yeah,
yes.
so
Yes.
it has a deep meaning. So be careful in the
So
interview. You have to
omega.
be very careful. Okay. Yeah.
The omega is the parametric space.
Okay. So oh, and what is g theta?
G theta, any parametric function, a function of the parameter theta.
So do you think that all parametric functions are estimable?
Uh, and not necessarily. Not all functions are estimable.
Then which of the functions are estimable?
If we can find a t such which satisfies this property, then we will say that it is estimable.
Okay. So suppose I say that x follows binomial n comma p.
Okay.
I have a single sample.
Hmm.
And so this I will give you an estimated TP equal to 1 by P.
Please write a question. No? Please write.
Yes. Yes.
So X follows binomial n comma P,
Hmm.
where the parametric space is 0 to 1,
Hmm.
P is 0 to 1, and n is something which you know. Okay,
Okay.
it's not a parameter.
Hmm.
So now suppose you define a statistic P, TP is basically 1 by P.
Okay.
So do you think this is estimable?
Uh, okay, so I think I don't think it's estimable.
Just try to,
Okay.
do whatever, go by the
Okay.
definition.
Yes. Also, can I write TP? It says GP. Okay.
Yeah, anything.
First, we assume that there is a function Tx that estimates GP. So, Okay, so we can proceed. So I mean, this should be true for all P. So I don't think we'll get any value of Tx which will satisfy this. I mean, I can write it like this. I mean, it is an identity in P, and if we uh, compare both sides, then we won't get any value of T naught which satisfies this identity. So I think we can say that
Can you
it's
tell me any one value of P for which the both sides are not satisfying?
one value of P.
Yeah. I mean, that will suffice, I guess.
Okay. Uh, I mean, if I mean, 0 and 1 would be such choices, I think. 0 for 0, P equals to 0, this doesn't have any.
Okay, for P equal to 0, what you are getting in the left part?
Left hand side, it will just be 0. But I think 0 is not in our
No, but
parametric
I
space.
think you have written the parametric space a bit wrong. It will be from 0 to 1, in both inclusive.
I mean, if we include 0 to 1, then 1 upon P will not be defined, no, I think.
Yeah, that is true. So, I mean, you can define 0 exclusive P, like 1
Ah,
inclusive, then
yes,
also
yes.
that works.
Yeah, P equals to 1 also works. Yeah.
For binomial distribution, you can have a parametric space, but you can have a estimator or a parametric function for which it is invalid.
Yes.
Right?
Yes, yes.
Okay, well said. So, here's my next question. So, suppose you have X being one single sample, okay,
Okay.
and you have one more estimator, which is like Tx, and that Tx is A plus Bx,
Okay.
right? It
I mean, X is following any distribution or just a.
no,
Okay.
it is just a single sample.
F dx is Px. Like this.
Right? Okay. So now this A and B are constants.
Okay.
So what is Tx? I mean, what type of estimator this is?
I mean, a linear estimator based on X, I think.
Now, if I say that X follows normal theta comma 1,
Okay.
where the parametric space of theta is the real number. Theta belongs R. Okay. So now what we want to estimate theta, right?
Yes.
As you can see that there can be infinitely pairs of A comma B,
Yes.
such that there can be infinitely many statistics.
Yes, yes.
So what do you think? Which pair of A comma B will you take?
If I want to take, then I will take the pair which has minimum variance, I think.
Minimum variance, are you sure?
Mhm. I mean, it should be, I think, minimum MSC, and if we incorporate the unbiased property, then it will be minimum variance.
Yeah, I mean, over here, I have not given any constraint about it being unbiased
Okay.
or biased. So this is a general
Okay, then
question.
I will take the pair which has minimum MSC.
Can you write a few things?
Okay. So I think I can write the MSC as. I mean, this will be a function of A and B, right? So, uh,
So what do you want to do with your
okay.
MSc?
I mean, I want to minimize it with respect to A and B.
Okay.
So I think let me first get the expression of MSC. Okay, so this would be variance. I think the expression of MSC should look something like this.
Okay. Then what you will do?
I will try to minimize MSC with respect to A and B, I think. And that choice of A and B will be my desired result. But I think this one equation, I mean, I only have one equation, so I think uh,
Okay, tell me one thing. For which choice of A comma B will this be an unbiased estimator?
hello, sir, I'm audible.
Yeah, you're audible.
Okay. I was having some internet issues.
Yeah.
Sorry
So
about.
my question was,
Hmm.
for which choice of A comma B will, I mean, it can be multiple choices also. I'm just
Yes.
asking that for which pairs of A comma B will this TX be unbiased estimator and will it be unique or not?
Okay, if only we're saying unbiased, then no. It not necessarily have to be unique.
Can you
There.
show any two pairs of A comma B for which TX is unbiased?
Wait. Let me just write this. Okay. It yeah, as it stands for all theta in the parametric space. So this will be there will be a unique choice, and which is A equals to 0 and B is 1.
Okay, so you will always get a unique unbiased estimator in this case, right?
Yes.
So can you tell me what is the MSE of this unbiased estimator?
Okay. MSc of the sun. I mean, it will be 1, right?
Just do it. Why?
Oh, okay. So here I'm getting A equals 0 and B is 1. So B is just X. X is just variance of X, and which is 1.
Okay. Now just draw a plot of MSc versus theta. Just like in y-axis, you will have your
Yes,
MSc, and in x-axis, you will have your theta.
uh,
Okay. So now can you draw this MSc in this plot? The MSc of unbiased estimator?
okay, so I mean, it will be 1 for all theta.
Yeah.
So
So how will it look like?
something like this. 1.
Great. So this line corresponds to a pair A comma B, which is 0 comma 1, right?
Yes, yes.
Great. So do you think that there can be any other MSc, which is of course not unbiased? We saw that this is an unique
Hmm.
unbiased estimator, which
Yes.
can go below this?
I think there, yeah, there can be, right? I mean,
So, okay,
there can be some
let us
unbiased.
consider one
Hmm.
another estimator, say
Okay.
T2x or anything.
Hmm.
Uh, say 1 plus x by 2.
Okay.
Can you do the similar
Okay. Okay.
findings? Yeah.
So I'll find the MSc, right?
Yeah. Okay,
Yes.
good. So can you draw that in the plot?
Okay. So okay. Theta is 0. I think this is 1/4 plus half, right? I think it will look something like this. This theta is 1.
Okay, so you can see that this curve do have some
Yes.
MSE values which are less than 1, right?
Yes.
So do you
Yes.
think it's better to estimate theta?
Uh, and we can't directly say that, right? When theta is in that range, when it is below, then it's better. And for, I mean, larger theta, it's not.
Okay, fine. So now we have this MSE expression, right? MSE equal,
Yes.
we have written MSE of Tx minus theta.
Hmm.
So can you split this by any chance in terms of
Uh,
variance and bias?
yes, yes. And will I write the result or the derivation too?
You can write the result.
Okay.
Can you tell the first step of how to extract variance and bias?
Okay, so I will inside the expectation, I will just incorporate expectation of Tx plus
Oh,
and minus.
fine. So, like, what is the significance of MSE when we try to estimate any parameter, any parametric
Okay,
function?
so it measures the deviation of the parameter from the actual value of theta. I mean, the square deviation.
Okay. So, what is our goal over here while we try to minimize MSE?
Our goal is to get the values of the estimator as close to theta as possible. So to minimize the deviation from theta.
Okay. So, just write another function,
Okay.
function of t actually. Yeah.
Hmm.
So, this function is say expectation of modulus of Tx minus theta.
Okay. Hmm.
This also, I mean, satisfies what you said just right now, right?
Yes, yes.
So
Absolutely. Sure.
why do we not use this? Or can you use this?
Yeah, I mean, we can use this, but I mean, it's a little tough to deal mathematically. I mean,
Okay.
conceptually, I don't think there is any problem with dealing with this.
I mean, any drawbacks of using this function? You said that conceptually it is fine, but mathematically we cannot do it. Why?
I mean, when you try to minimize, as this modulus function is not differentiable, it may cause some problems.
Okay. Okay. So are you aware of any numerical techniques to solve?
Uh, I mean, numerical techniques to minimize this function.
Yeah, I mean any function that is not differentiable.
No, I don't think I do.
Okay, no problem. Okay, anyone, sir or Ananu can take
Uh,
over.
okay. So, Sanmitra, I have a question for you.
Yes.
What is sufficient statistics?
Okay, so sufficient statistic is a function of, uh, I mean, it's a statistic when the conditional distribution of any other statistic with respect to this one is independent of theta.
Just right.
Okay.
Mainly conditions, not all terms of
Yes,
the
yes,
function.
yes. Hmm. You think?
Okay. Then
And the distribution of T dash condition to T is independent of theta for any other statistic T dash.
okay. So if T is sufficient statistics
Yes.
and fx is one function, then
Okay.
then f of t is sufficient or not?
Yes. F of T is also sufficient.
So what will you say about if f of x is not 1 1?
Then we can't surely say that it's sufficient.
Okay, so just write an example where fx is not 1 1,
Okay.
but f of t is sufficient.
Okay. Not 1 1, but sufficient, right?
Yeah.
Oh. I think this can be an. Let me just write it. Okay, so we consider this normal 0 sigma square and okay, so the sufficient statistic of sigma is this one. But if we take square of this function, I think this can also be sufficient for sigma, but it's not a 1 1 function.
It's not a 1 1 function.
If
Means आपका ये जो 1 1 फंक्शन होता है, क्या पूरे आर में हम कंसीडर करते हैं कि केवल आप सपोर्ट मींस पैरामीटर स्पेस में कंसीडर करते हैं?
yeah. I think पैरामीटर स्पेस में ही कंसीडर करेंगे ना, ठीक सही बोले.
हाँ, तो दिस इज 1 1 ना?
Right, this is 1 1. Okay. Then I
Think
don't
about Bernoulli distribution. I think you can easily find it.
Bernoulli.
Consider a sample of size 2 only, then
Okay.
you can easily find it.
And
You know that x1 comma x2 is sufficient.
yes.
ठीक है, define a function x comma y equal to x plus y.
Okay. So
Define a function f x comma y
yes.
equal to
Plus
x plus y, where x comma y belongs to 0 comma 1.
yes. Okay.
Okay, so this is 1 1 or not? I think this is not 1 1.
Right. Yes.
या
Yes, this
x
is
कमा, हाँ x कमा y बिलोंग्स टू 0 to 1 लिख सकते हैं, हाँ ओके। आई थिंक दिस इज नॉट 1 1, बट
yes,
f ऑफ, हाँ, but x1 plus x2 is sufficient statistics,
yes, x1 plus x2 is sufficient.
using factorization theorem, right?
Yes.
ओके ओके, हाँ नॉन में आपको कुछ पूछना है?
Actually, I have a question from you. Can I proceed?
Yes, yes, please.
Yeah. So, suppose you have two statistics, U and V. Okay.
Okay. U and V.
And yeah, U and V, and U is sufficient.
Okay.
Fine. And V is a function of U.
Okay.
Any function of U.
Okay.
Can you write the question? Yeah. So do
Like
you
this.
think that V will also be sufficient?
Yeah, no, not necessarily.
Okay. So is there any restriction on F?
I mean, I think F should be an 1 1 function of U.
Okay. So is it true that if F is a many one, then it is not sufficient?
I mean, for an example, I can say that x bar is sufficient for mu, but x square is not necessarily sufficient for mu when mu is when the parametric space is real number.
Okay, no, my question is it always true that for many one
No,
function?
no, 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 not always true, of course.
Why do we use sufficiency?
What do you use? Okay. One of its uses can be to find the uniformly minimum variance unbiased estimator.
No, my question is
But-
like, why do we need sufficiency as a property of our estimator?
Oh, okay. Uh, I mean, I think sufficiency, I mean, it implies that it has all the necessary information about theta. I mean, our parameter unit.
So just write two statistic.
Okay.
T1, which is basically say x1, x2, dot 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 xn, your vector.
Okay.
And T2,
Hmm.
which is say x1 plus x2,
Okay.
comma,
Hmm.
x3 dot 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 xn. So, I mean, are both the statistics sufficient?
Yes.
Okay, then if I give you to choose between one of the two, which you will choose and why?
Uh, I think I will choose the second one because I mean the first one is a n component vector, second one is an n minus 1 component vector. So I mean it compresses the information better thing.
Okay, so
I mean our parameter is a single real value parameter, right? So I mean the lower the dimension of sufficient statistic is, I think, the better.
okay, so for I mean, I think the similar thing will also do if you use a many one function, right?
Can you repeat? I think the network connection was a
Yeah.
little unstable.
So yes. So my question is, as you mentioned that T2 will have a lesser dimension, so maybe we should go with T2. And you can also
Yes.
see that is just some transformation between T1 and T2. Do you agree with me?
Yes. Yes. Yes.
Okay.
Yes.
So I mean, just T2 is some function of T1 only, right? So
Yes.
my question is, just going back to the previous question. So if we use a many one function, I think it will also do the same thing, right? I mean, it will just reduce the dimensions.
Yes. That is true.
So do you think that if that is true, then every many one function will be sufficient always?
Uh, no, I mean that still shouldn't be the case, right?
Okay, fine. Well, no, any questions?
Yeah. I have a question for you from linear algebra. So,
Okay.
what is characteristic polynomial? Just right.
Okay. So if A is an cross n matrix, then characteristic polynomial would be okay. This will be our characteristic polynomial.
Okay, yeah. So, what is idempotent matrix?
So A square equals to A. If a matrix satisfies this condition, A square equals to A, then it's idempotent.
Okay, yeah. So, write a minimal polynomial of idempotent matrix. First of all, what is minimal polynomial?
So minimal polynomial is a
Just write and then think. I think you can easily find it.
hello, sir.
Yeah.
I think
Share your screen.
sir.
So what is minimal polynomial?
Okay, so it is a I think minimum degree monic polynomial that divides our characteristic polynomial.
Means what is monic polynomial?
Where the highest degree coefficient is 1.
Okay, so if x square plus x is a minimal polynomial, sorry, suppose x square plus x is a characteristic polynomial. Here
Okay.
x divides x square plus x. So then x is minimal polynomial according to you.
Uh, oh no, I think I missed a point. I
Okay.
mean the minimal. I think if I input our matrix in the minimal polynomial, it should give the null matrix.
Okay. Right. So then write the minimal polynomial of idempotent matrix.
Okay, so it will be x into x minus 1, I think.
Are you sure?
Yes, I mean idempotent matrix follows the condition that a square equals to a. So we can say that a square minus a is null matrix. So I mean in case of I think null matrix is also an idempotent matrix, right? So in that case, I think just x will be its minimal polynomial, and in case of uh, identity matrix, x minus 1 will be. But in all the other cases, I think x into x minus 1.
You are saying that if X A is nilpotent matrix, then sorry, null matrix.
Null matrix, yes.
Okay. So if ax square equal to a, that means ki a is idempotent matrix, right? So what is the eigenvalue of idempotent matrix?
Either 0 or 1.
Either 0 or 1. Okay. तो बोथ मीन्स 0 और 1 नेसेसरी है कि 0 और 1 दोनों ही होगा या केवल 0 या फिर केवल 1?
Yes, in case of null matrix, it can be 0 only, or in case of identity matrix, it can be 1.
Can you write an example of idempotent matrix of 3 cross 3 matrix? Yeah, 2 cross 2 matrix. Just write 2 cross 2 matrix.
Oh, okay.
Where A is not identity or null matrix. Okay.
I think this will be an idempotent matrix.
Okay. Yeah. Okay, fine. देव, आपको कुछ पूछना है?
नहीं मुझको कुछ नहीं.
Okay, तो what is Cauchy sequence?
I mean, should I write the definition?
हाँ, yeah.
I think the sequence satisfying this condition should be Cauchy sequence, or called
Okay.
Cauchy sequence.
Yeah. So is every Cauchy sequence is convergent?
Yes, every Cauchy sequence is convergent.
Oh. Are you sure?
Yes.
Okay. Write example n equal to 1 upon n. N equal to
Okay.
n equal to 1 upon n. Where 1 upon n belongs to?
So 1 upon n belongs to
open 0, 2 open. So this is convergent sequence or not? First of all, this is Cauchy sequence. This is Cauchy sequence.
I mean, no, 1 by n is not a Cauchy sequence.
1 by n not a Cauchy sequence. Proceed with definition. Just write definition. Just proceed according to definition.
Okay. You mean this one, right?
Just simplify this.
Okay, okay. It, uh,
You have to find epsilon. You have to
yes.
find epsilon.
Yes, yes.
Suppose m less than n, then think.
Yes, I mean, I can write this, right? The aim is, okay,
Yeah, just first thing triangle inequality na. No, first
yes,
thing
yes,
triangle inequality. No,
okay.
apply triangle inequality. Yeah,
Triangle inequality is I mean 1 by m minus 1 by n पे क्या?
yeah. Mod x minus y less than. क्या
Okay.
होता? What is triangle inequality?
Mod x minus y is less than I think mod x plus mod y होगा.
Yeah, yeah.
So it will be just 1 by m plus 1 by n.
Yeah. Now, if m less than n,
Okay, okay. So I think I can write this. M is less than n. I mean, I can write this, right? ये
yeah,
होगा ना?
हाँ यही होगा. This is
Okay,
less
so
than
if
epsilon.
this is
For m greater than
yes, yes.
2 upon epsilon. Yeah. So this is Cauchy sequence now for every epsilon. For by Archimedean property. For every epsilon, for means what is Archimedean property? Do you know? Are you okay?
Sorry, sir. The
No
internet
problem. No.
connection is very unstable here.
हाँ.
Can you hear me, sir?
Yeah.
Okay, so let me just. Yes, sir.
So apply Archimedean property. This is right. Okay. So this
Yes,
is
yes.
Cauchy now.
Okay, okay. Yeah, we can say it's possible. Right.
Okay. So this is convergent or not?
No, but yeah, okay. 1 by n, it is convergent, right? No, the sequence is convergent. Sorry.
Sequence is convergent.
1 by n 0 to 2. Okay.
1 by n converge in R या close 0 to 1, not in open 0 to 2. Sorry, 1 by n converge in real number या close 0 to 2, close
Okay.
interval
Okay.
0 to 2, not in open
Pen.
interval 0 to 2. So this is Cauchy but not convergent in 0 to 2.
Okay.
हाँ, तो जो
Understand.
आपने कंडीशन बोला, तो ये कंडीशन होता है if sequence in real define in real number, if sequence define in real number,
Okay. Real number.
हाँ,
Then
then if sequence is convergent, if and only if it is Cauchy sequence.
cost.
यानी
Okay.
Cauchy होगा तो convergent and convergent होगा तो Cauchy होगा in
Cost
R.
in R. Okay. Okay.
हाँ, ओके ओके फाइन ओके.
Yes. Yes.
तो हाँ, आप कोई फीडबैक देना चाहते हो कुंदू?
No, your approaches are quite good, but be a bit confident while answering the questions.
Okay.
I mean, थोड़ा लगा कि शेकी हो रहा है कभी कभी,
Uh,
and like अभी भी time है, so maybe you
hmm.
can just go through the text once more.
Yes. 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 I
And
will. I will.
like till now, what you have done is you have just solved a lot of questions for JAM or maybe for ISI,
Yes. Yes.
but try to understand statistics as a whole from the very scratch, because
Okay.
like what you will get in real life is your data. Okay.
Yes. Yes.
Then, so you know everything that we can feel. All the topics, you know, Emily, it can be estimation, can be testing. But why, like, where will you use in real life? That will give clarity
Okay.
to your interest.
Okay.
Okay.
Yes,
हाँ,
sir.
तो आपने
Thank
इंटरव्यू
you, sir.
दिया, तो देखो 1 आवर्स का आपका ऑलमोस्ट इंटरव्यू हुआ, और
हाँ
हम
हाँ
1 आवर्स से क्वेश्चन ही पूछ रहे हैं, ठीक है? तो
हम्म
आपने देखा कि ज्यादा नहीं हो पाया, ज्यादा क्वेश्चन से राइज
हाँ
नहीं हुआ, तो
हम्म
वहां भी ऐसा ही होगा, ठीक है ना? यदि वो वन
हम्म
आवर्स का या 40, जनरली कितने मिनट का होता है समझे?
40 minutes. 40
40
to
मिनट, हाँ, तो 45 से 40 मिनट का आपका इंटरव्यू सेशन होगा मैक्स टू मैक्स, ठीक है? वो
हम्म
रेयरेस्ट ऑफ द रियल के केस होगा जिसका लास्ट में होता है ना, तो वो
हाँ
थोड़ा चिल रहते हैं कि चलो ठीक है लास्ट है तो हम टाइम दे देते हैं, कोई दिक्कत नहीं है। लेकिन जिसका बीच
हम्म
में होता है जनरली 30 मिनट, 40 मिनट, 45 मिनट, हार्डली हार्डली 60 मिनट,
ओके
तो इसमें ज्यादा क्वेश्चंस नहीं होगा। तो इसलिए मीन्स कूल रहना है, ठीक है ना, रिलैक्स रहना है
हाँ हाँ
और अप्रोच करना है, डायरेक्टली किसी चीज को माना नहीं करना है कि ये मुझे नहीं आता। आपको भले उसके बारे में नॉलेज ना हो, ठीक है आपको, लेकिन आप जस्ट थिंक अबाउट दिस,
ओके
कि
ओके ओके
ताकि उनको ये ना लगे कि आपने डायरेक्ट मना कर दिया, तो वो इसको ईगो पर लेंगे, ठीक है ना? वो ये नहीं आप अपने तरफ से इनोसेंट होकर के बोल रहे हैं, लेकिन हो सकता है कि वो ये कंसीडर कर ले कि आपके अंदर ईगो है, आप डायरेक्टली मना कर रहे हैं, ठीक है
ओके
ना? तो मेरे साथ ऐसा हुआ है, इंटरव्यू में मेरे साथ ये हुआ है कि मैं डायरेक्ट मना कर देता था, क्योंकि मुझे ये डर था कि यदि मैं जवाब दिया, थोड़ा
हम्म
भी अप्रोच लिया, तो वो इसमें क्वेश्चंस को ऐड करके पूछेंगे, लेकिन ये निगेटिव
हाँ
मेरा चला गया, ठीक है ना? हाँ,
हम्म
आप ट्राई करते हुए बेशक मना कर सकते हो कि मैं सर इसमें कंफर्टेबल नहीं हूँ, मैं नहीं
हम्म
सोच सकता हूँ, या आप प्लीज गिव मी सम हिंट, देन आई कैन ट्राई
ओके
इट। तो ये एक माने सही वे होता है, लेकिन डायरेक्ट जैसे वो क्वेश्चन पूछे, आपने कंप्लीट सुना भी नहीं और डायरेक्ट मना कर दिया, तो
हम्म
ये नहीं होना चाहिए। लेकिन आई थिंक कि वैसा क्वेश्चंस आएगा नहीं, फिर भी यदि सपोज आ गया, तो जैसे आपने बोला कि मेरा रियल एनालिसिस मींस उतना पकड़ नहीं है, वीक है, तो हो
हाँ
सकता
हाँ
है कि वो कुछ रियल एनालिसिस क्वेश्चंस करे, तो
हम्म
आप डायरेक्ट मना कर सकते हो, तो ये निगेटिव इम्पैक्ट जाएगा आप पर, ठीक है ना?
ओके
उसका
ओके
निगेटिव फीडबैक जाएगा, तो आपको कहे कि हाँ सर पूछिए, मीन्स आई कैन ट्राई, मीन्स मैं ट्राई
ओके
कर सकता हूँ, आप पूछ पूछ सकते हैं। अब ये नहीं कि नहीं नहीं सब बिल्कुल ही मत पूछिए, तो फिर ये दिक्कत करेगा आपको, ठीक है ना?
ठीक है सर
तो हाँ, तो जस्ट आपको अप्रोच लेना है, और कोई चीज आपको आ भी रहा है, सपोज दैट आपसे वो कुछ सवाल पूछे, आपसे बिल्कुल आ रहा है, जैसे
हम्म
एग्जाम्पल हुआ, काउंटर एग्जाम्पल, मेनली एग्जाम्पल, तो
हम्म
उसको डायरेक्ट नहीं सोचना, मैं डायरेक्ट नहीं लिखना है, आपको ये दिखलाना है कि आप सोच सोच के लिख रहे हैं,
ओके सर।
एक नहीं होता है मेमोरी में होता है तो हम डायरेक्ट लिख देते हैं, तो वो
हाँ
नहीं
हाँ
होना
हाँ।
चाहिए। उनको ये
ओके
फील
सर।
कराना है कि आप अप्रोच ले रहे हो, यानी आप कहीं से चीजों को कनेक्ट कर रहे हो, डिफिनीशन से कनेक्ट कर रहे हो, कनेक्ट करके
ओके।
आप एग्जाम्पल्स को लिख रहे हो।
नहीं,
ठीक है
एक
ना
सजेशन है इसको करने के लिए। तो तुम्हें पता है कि फाइनल आंसर क्या है? जैसे कि
हाँ
एक वो मैं जब एमएससी पूछ रहा था, तुमने
हाँ
बहुत
हाँ।
जल्दी दिमाग में कैलकुलेट करके वन बोल दिया। तो
हम्म।
इंस्टेड ऑफ जस्ट कैलकुलेटिंग इन योर माइंड, तुम लिखो ना एमएससी
ओके
किया है, जैसे
ओके ओके।
किसको पढ़ा रहे हो, ठीक है? आई मीन
हाँ
व्हेन
हाँ।
यू एंटरिंग द इंटरव्यू हॉल, डोंट थिंक दैट यू आर द कैंडिडेट ओवर देयर। जस्ट थिंक कि तुम ही वहां सबको पढ़ाने के लिए हो, दे आर जस्ट आस्किंग यू सम डाउट्स। दैट विल, आई मीन, बहुत नर्वसनेस कम हो जाएगा उससे।
ओके ओके।
तो इट्स फाइन और बेस्ट ऑफ लक। और
थैंक
बाकी
यू
थैंक
सर।
यू।
हाँ, ग्रुप में मैं मैसेज कर ही रहा हूँ, क्वेश्चंस को फॉलो कर रहे हो ना आप लोग?
हाँ हाँ हाँ।
हाँ
अब
तो, हाँ
उसमें।
तो वो आप लोग, वो काफी हेल्पफुल है ना, समझे?
हम्म।
हाँ हाँ, दैट इज गुड।
हाँ तो ठीक है, और बेस्ट ऑफ लक, और बाकी ग्रुप के अकॉर्डिंग प्रोसीड करते हैं। चलो।
ओके सर, थैंक यू सर।
ऑल द बेस्ट।